In this chapter, we're going to introduce the vector. A vector is a data structure that allows you to store multiple values within a single name, which is opposed to a variable which lets us store a single value in one name. Vectors give you lots of advantages over single variables when you have a lot of data that are related. Rather than give you a formal introduction to vectors, what I'd like to do instead is show you an example to show you how effective vectors can be when dealing with larger groups of data. Take a look at the program in front of you. We have 5 grades that we're going to store values into. So each of these is defined as an integer. Then we have an average variable which is declared as a double, and an int variable numgrades which stores the number of grades that we're going to store and will be used to compute the average. So let's continue on with the program right here. You'll notice that we've already prompted the user to enter all the grades and gotten them into the variables. So the next step is to compute the average. So we'll do that now by summing all the grades. And then dividing by the numgrades variable. I'll move down to the next line to make sure we can have room for everything. Now all we have to do is display the average, like so. So let's build and run the program. We'll try it with some even numbers, 90, 80, 70, and 60, and the average is 80. Now the problem with the program like this is that what if we had 50 grades, or 100 grades, or 500 grades? Writing a line like grade 1 plus grade 2 plus grade 3 plus grade 4 would get pretty ridiculous if you have to do that several hundred times. So instead we need a data structure that can store all of the data that we need in a single name, and that's what a vector does. So let's show an example of using a vector for this problem by first commenting out the code that we've already written and starting over. The first thing we need to do when working with a vector is include the vector class into our program. So we'll do that now. We'll leave a space there. And I misspelled include, so let me fix that real quick. No problem. Now we're ready to declare the vector. A vector is declared with the vector keyword, followed by an open angle bracket or less than sign, followed by the data type of the values you want to store in the vector, in this case int, followed by a close angle bracket or a greater than sign, and then the name of the vector. In this case, we're going to call this one grades. Then we need a variable to store each individual grade, and then we need a variable to store the total. And then, of course, we also need a variable to store the average. Before we go any farther, we also need to initialize total to 0 so that when we add vector values into total, we don't get an erroneous value the first time. That happens a lot when you use variables that have not been initialized. So anytime you're going to keep a running sum, as you're going to see here, you should probably initialize that variable that's going to store the sum. Now, to get the data into our vector, what we're going to do is we're going to write a loop that prompts the user 5 times to enter data. So we'll start our loop at 1 and run through 5, incrementing I by 1 each time. The body of the loop will consist of the prompt, enter a grade, followed by a cin statement to get the grade in, and then a statement to add the grade to the vector, and we do that by calling a method from the vector name called pushback. Type it in like so. So what happens with pushback is pushback takes its current value, or the value that's passed to it, and stores it in the first available spot in the vector. When you declare a vector like we did above, it's empty initially. So the first time we call pushback, it's going to put that value in position 0. The next pushback puts the value in position 1, and so on and so forth. And it'll just keep adding until we run out of data to add. So that's all we have to do to put data into the vector. So we'll close the loop. Now, just so we can see that our data actually is stored there, let's write another loop to display that data. This time we're going to start at 0 because that's the beginning position in the vector. And then rather than go through 5, we're going to go through the size of the vector by calling another method size, which returns the number of elements in the vector. Notice that we did I less than grades.size rather than I less than or equal to grades.size. because we don't actually want to go to the fifth element. We want to stop at 4 because our 5 grades are stored in positions 0 through 4. Increment I by 1, and then in the body, we'll just write out the value, and the way we access the values in a vector is by using a subscript notation, which is a square bracket, open square bracket, followed by the variable I, followed by a closed square bracket, although we normally just call that a subscript. Then we want a space, and then we close off the statement. So what's going to happen is, as the loop goes from 0 through 4, each time when it's 0, for example, at grade sub 0, it's going to pull out the first grade. At grade sub 1, it's going to pull out the second grade, and so on and so forth. Let's build and run the program and see how it works. So we'll enter the same grades we entered before. And there you see that it displayed them out. So now that we know the grades are stored correctly, we can go ahead and get the total and compute the average. Rather than rewrite the loop, we'll just use this same loop, take out the cout statement, and add in a statement to add each grade into the total. So rather than write them out like we did with cout, we're just going to add them to the total. Then when we're finished, we can compute the average, which is equal to the total divided by, now we don't have a variable numgrades like we had before, but we have something that's even better, the size, which we can use again. This time we can use grades.size as the denominator in our statement to compute the average. Now we'll write the average out. In with an inline. Let's build and run the program. Enter our grades. And we see the average is 80, which is exactly right. So as you can see, by comparing the code without the vector to the code with the vector, using vectors provides a more efficient way to store multiple data items and then work with those data items once they've been stored in memory. In the next video, we'll look at different ways of creating vectors.